Good afternoon. Hope you are having a good time. We had two amazing talks before, so hoping to continue the trend. So first of all, let me introduce myself. So myself, Ashwin. I work at Platformetry, and we are a niche consulting firm. So we do consulting around any real-time architectures, like including Kafka, Druid, Pinio, to name a few. So myself personally, I have worked with half a dozen retailers, in addition to a lot of other companies from finance sectors, entertainment industry, etc. So luckily I had a chance to work with Misho as well, so which adds a bit more context to this. So without further ado, let's get into the talk. So my talk is going to be around a real-time retail, right? So we know that nowadays it's an age of digital streaming. A lot of e-commerce has overtaken, all the in-stores and things like that. You don't really walk into the stores and buy stuff anymore. Rather, you want to look into a website and try to understand how the product is performing, right? So see the reviews and such, and see which is the product I want to buy according to my budget and such. So in this age, it's very important to have, as a retailer, you need to collect the data, which is you're procuring from the customers, as well as based on your products, the inventory data, whether how much is selling right now, what is going to get out of stock and things like that, and aggregate them, all of them, so that you can build a data platform around it and start building, models and pipelines or analytics around it. So to explain it in a nutshell, there are 4 capabilities which we talk about when we are talking real time. You need the technology to be in place. I mean, you can't do with the legacy system like databases and things like that. That will get you to some extent, but if you want to achieve real time analytics, so you need technology like Kafka. So that is pretty much a requirement to get started with. And also, in addition to the data side, you need technologies to basically input data in real time as well. So all of your vendors and all of your stores and everything, they should have the technology or the devices through which you can input the data and make it available in a data platform. So all of that capabilities need to go into account, and your thought process have to be in such a way that all the technologies are covered so that you can achieve this. Now the second part is, once you have the data, you have data into a unified data platform. Now the next step is to do analytics on top of it, right? So you have your own models, like anything ranging from like a customer clickstream data. You try to understand how they are showing interest towards which product and how is it selling the product. And if you take in the advertisement side, right, like how do you want to optimize your ad spends, right? So how do I want to say, okay, this product is going to sell through this particular season, and probably I want to spend my ad money on that more rather than the other products, right? So for that, all of that, you need data and analytics, and you have to start building the models out there. So the next one is the operation side of things. So which, as I mentioned, so once you understand, you spend money and you make your customers show interest in your products, it's your responsibility to make sure that the product you're selling is there, in the right stores. For example, let's take Flipkart, right? So we see a product we want to buy, like how much time does it take for us to arrive at home, right? So it might take 6 days, 7 days. So which actually adds a negative trend to your basically customer experience. If it is available, let's say in 1 or 2 days, it's going to add more value, and your customer is going to like that more. So all this experience can be sorted out by having optimize the inventory, and also if you see from the retailer side, they need to also procure the said products from the other manufacturers and stuff like that. So for that, you call something like fulfillment, right? So you want to order fulfill, so based on the demand you are seeing. Now, and the fourth point is about operating model. So obviously you should have a clear hierarchy and a flow of stuff, so that the data or even the products, the flow is pretty defined. So that's what operating model is. So we are going to, We are going to cover in this talk mostly about these two parameters, like that is data and analytics and the operation side of things. So some numbers from the real world, right, to understand why this is important. Why do we even need to do this in the first place, right? So if you see Amazon, right, so Amazon, very interestingly, the recommendation engine you are seeing in the Amazon e-commerce platform actually drives 30%, 35% of their revenue. So which goes to show that giving the right, or basically showing the right products to your customers will actually, take you a long way in terms of earning more profits. And if you see, there's a parameter called customer lifetime value, right? So this keeps increasing as your customers are like more and more ready to buy your products you're showing. So it's very important to have a good recommendation system as suggested by Amazon here. And similarly, if you see, there is a study by IDC which shows that real-time analytics, if you have it in place, you can actually reduce your total cost in terms of inventory by 15%. So, and by reducing the inventory, you are also, improving your sales as well, because it's the other side of the coin, right? So if you have optimized inventory and everything, you're not going to lose out on, overstocking, or you're not going to lose out on, like, potential sales, and you didn't have the stocks to, satisfy that. So all of these things can be resolved by having a good real-time analytics platform for you. So next, we want to talk through what is the hierarchy of data management, right? If, like, let's say we decide that we want to build this capability as a retailer. So what are the things you need to consider? So the first thing would be, first you need to gather all the data, right? So without that, you can't even go to the analytics side of things. So to gather all the data, that too, in our case, it has to be real time. So for that, what you need to do is, as I said, you have to enable all your channels, across channels, like if it's a big store, like they will have, online stores, offline stores, and, warehouses, and, potentially delivery and everything. All of this data needs to be brought into a unified data platform. So only then, the microservices or the services you have underneath can pick those data from different streams, and then, like do some joins, or even after that, you can build your own ML models out of it, and then you can serve the models and basically make them available for predictions through real time. So, as I said, so it is the inventory visibility as well as the combination of all the channels across the real time. So the second part is, once you have the data, then you start thinking about what are the models I will need to build, right? So basically, the two important models would be, like demand and supply forecasting. So those are the two sides of things, right? So what is the demand you're seeing from the customers, maybe through, clickstream data, or through, like ad spends. You're seeing that which ad channel is actually, like contributing more to the attribution. And similarly, for the supply side of things, again, you will need to predict which one is going to sell through. Probably this product is highly likely to sell through this season, basically. So these are the forecastings you will need to do based on the historical data and make it available. And then once the real-time data comes into picture, you like use the models and get the predictions for that. So two important features by demand and supply forecasting is dynamic pricing and fulfillment speed we are talking about. So dynamic pricing is basically, you see that customers, right, like they want to see which, for example, Amazon and Flipkart, if I can take the names, so right. So I'm going to go compare the same product in both of them and see which is offering me less, price. I'm more likely to go and buy that. So important metric is to have a good pricing system, so that you entice your customers to come and buy your product. So what are the factors which goes into dynamic pricing, or basically, as I said, segmentation. Basically, you take a segment and try to understand this segment is showing more interest in these products. So I would want to offer a slashed price for this segment when compared to the other segments. Tricks you can consider to arrive at the dynamic pricing. But there is a flip side to dynamic pricing, which is to obviously, if you customize a lot, right, so you end up, showing yourself that your prices are very volatile, right, and your As customers, you might think that I'm being offered a different price than that person. So all these different things are there. When it comes to negative things of dynamic pricing, you have to be very wary of how you are doing this. Ideally, if you are doing it in a segment level, then it makes more sense to do it rather than a customer level. So, see, ultimate point of what we want to do here is like once we have the data, then you have the models out there and everything. Finally, to maximize your CLV, right? So the important thing is to have a very personalized customer experience. So, so for example, as a person, me, right? Like I'm going to buy something from Flipkart, let's say, and the next thing I want to see under my recommendations is like an additional thing for us. Like a good example would be if you go buy a mobile, right? Obviously, you're going to see the the mobile cover and then the screen guard and everything, right? So this actually adds value, and it also puts me in a position to go buy this. If it's readily available, everything is available in that particular place. I don't need to go and search for it outside. It actually makes the buying process very easier. So this is a small example of what a personalized customer experience can do. But in addition to this, you can do a lot more capabilities as well. So these are the main retail ecospheres we are talking about. So as I said, omni-channel marketing, right? So you have different marketing channels. So some of them can run, like billboards. Some of them can run, ad campaigns in Google, Facebook, all of them. So it's important to understand which channel is, giving you the more attribution. So when I say attribution, it's like what is the conversion rate of the customers, right? Like when you spend so much money in the ad, right? So how much of customers are actually clicking the ad, coming to your website, and like after that, like how many of them are actually just browsing the product, looking at different variants, and then but some of them who end up buying the product. So obviously your goal is to make them buy the product, but all of the other things also add some value to it. Probably like a customer might show interest, but he might be looking for a little bit of a lower price. So in that case, if you have the data, you can go and offer a little bit of discount, saying that if you buy these two products, we will offer you so much discount, like 5 to 10% discount. So this might end up converting your customer as well. So it's important to understand the different marketing channels you have and try to understand which channel is giving you more attribution and spend more money on that channel to maximize your customer lifetime value. Now, another one is, like I said, the customer behavior, which is the continuation of what the channel I talked about, which is like basically we're trying to understand how many, add to product has happened for this particular product, right? And who are the users who have done that? So are they part of the particular segmentation of users? Now we can go target this particular segment and spend our money, ad spend on that particular segment. So to understand all that, you need to have the customer behavior. And also one more thing you can do is like based on the customer behavior, right? So you can clearly understand that some of the products you have are showing more demand. So obviously those products going to end up with more, like add to carts or like content view or something like that, right? So it goes to show that your product is highly likely to sell through. So it also means that you, as a retailer, you need to make sure the product is available. So what I can do is I can go, like place an order from the manufacturer for this particular product and maximize that, the fulfillment of that product basically. So all of these things can be understood from the customer behavior. So all in all, it's like a demand side of things from the customer you can understand. And if you see the product catalog, so it's basically, so what are the products you're having? You can have multiple products, how many variants of the products you have. It's basically the inventory of products you have, the features you offer from in the products, right? Those are the ones which we cover in product catalog. The inventory management is actually, like I mentioned, like are you having enough stock and do we need to fulfill the stock and those kind of things. Now, all of these things, like if you see the intersection of all of these things, that leads to deep personalization. So basically you if you want to give that customer experience, a personal customer experience, all of this, spheres have to be, like the data has to come from all of these spheres. You have to unify the data. You have to build your microservices which are going to read this data and build the models and slowly evolve the models as well as we go. All of these things need to happen for you to finally achieve deep personalization, which will in turn, lead to more ROI for you as well, because your customer lifetime value you are trying to improve, which actually leads to more ROI as well. Now, so based on, different retailers we have seen, a barebone architecture of sorts will look like this. So basically, you have your system of records, right? So it can be like, Shopify or, Salesforce or any ERP tool. So basically, you need to bring those data into the event bus. So event bus can be like a Kafka or anything similar to Kafka, okay? So you need to bring this data into it, and the CDC data, obviously. Once you bring into it, then you have the data of the inventory and the orders and sales and things like that. In addition to that, you have data coming from the clickstream, from your app. So from your app, you will need to direct or what are the, basically how is your customer interacting with the app. Basically, you send that data, that also into the Kafka or event bus. And finally, you have something called a customer 360. So which is nothing but you have built a profile of the customer, right? So what is the preference of this customer based on the history of the customer with your particular retail. So which includes like, okay, these are the buying history of the customer. These are the interests shown by the customer and what is he likely to buy, which segment does he come under, and all of these things will be there in customer 360. Now, once you bring in all of these three data, then it is the job of the microservices, right? Like you have a different microservice for different applications, right? So for example, you have something for dynamic pricing. So you determine what is the price this product should have at this point. So do I need to go and change the price? Do I need to reduce it at this point so that I can increase the conversion? And similarly, if you see the product recommendation, like I talked about with Amazon, right? The system has to be very real time and aware. Okay, this customer, he is particularly interested in this now, so this is the recommendation I need to offer. So all those capabilities need to be done. So your microservices are always reading from the Kafka, right, or the event bus, and basically it after doing the prediction or after doing the analytics, it writes back to Kafka. Now once it writes back to Kafka, you can have downstream systems like your applications, your front end, everything, which can take the data and show that to the customer. So like I said, this microservices, right? So the microservices itself can start. So obviously, when you start with things, you might not have all the data, you don't have a model. So you are in the phase of collecting data. So then all you can do is like, you do some rule-based algorithms to, say based on your, domain knowledge and such, and start with that. So microservices can just be a rule-based system for initially. Once you have data pumping in, right? So it's important to start building your models from data. So that most likely it will be like a supervised learning, including your domain knowledge which you already have. You try to apply ML models, and try to build a model for achieving the particular use case. Now, once you have that supervised learning, and this is what intelligence of the microservices looks like. Now is going to be you are going to use a Shopify data. So you have a Shopify account, and from where you're going to change some inventories and basically capture the change which is happening in Kafka through a connector. And then using that data, then you have a clickstream data which is coming into the Kafka as well. You join them, and then basically you send it to two microservices which are talking through HTTP API. And you try to understand how they are returning the predictions and things like that. So that's what I want to show now. What I have. Oh yeah. Okay. Can everybody see it? Obviously, I'm not sure about the people in the back, but. One more. Okay, so I just want to talk through what I have here. So if you see, I have a Kafka setup So here I have a broker which is running with KRF mode. So, and afterwards I have a connect cluster as well, just one node connect cluster. So after that I have a KSQL server as well, because we want to do the joins and we want to do the aggregation. So we have the KSQL server. And then I have the APIs for the microservices. So these covers the services I have here. Now, so this is an, not sure if it, show it here. Okay, first I want to just look into an example clickstream schema, right? So how will an example clickstream schema will look like? So basically we don't this is just for demo purposes, okay? So we have something like IP from where the request has originated, and then you have then you have options like user ID. Then obviously who's the user who's performing the particular action, and what is the time he's performing, and then you have what is the product variant ID is interacting with, right? So obviously you will need variant level information to basically correlate that with any of your inventory side of things or product side of things. And then finally you have options like activity, right? What type of activity has he performed? It's going to be a content view, add to cart, or he's made a purchase on this particular product, right? So this covers what clickstream schema will look like. Now I'm producing those clickstream data using a data source connector in this scenario. So after that, what we are doing is, so this is one thing which I wanted to talk about. So basically you have Shopify, right? So we actually, during one of our engagement with the clients, we had a necessity of developing a connector where you pick up the CDC changes from the Shopify streams, right? So for example, you go change an inventory in Shopify, that gets basically Shopify has a way of showing those changes through a webhook actually. So what you need to do is you need to go scrape that webhook and get the data. So what we have done is we have developed this custom connector which basically sets up that endpoint through which the Shopify can post its results to, and basically then you can that data gets written to Kafka through a source connector. So this is the JSON file for that. We'll share the link so maybe you can all take a look at it later as well. So now afterwards, once the data comes in, we will need the KSQL queries, right? So what this KSQL queries does is, like, first it reads the data which is coming in from the Shopify as well. So which includes your title, inventory item ID, inventory quantity, SKU, price, product ID, variant ID, and things like that. So once that comes in, then you start building a stream called products updates. This is just taking in whatever information you need and leaving out rest of the information you don't want. So basically it is just filtering of sorts. And then you have the clickstream data, which is there in a topic as well. So I'm just picking that up, same schema as I mentioned before. Now, only thing is, clickstream activity is going to make sense when you have an aggregated value, right? So I want to see, okay, for the last 1 hour, this is the interest shown by the user for this particular product and such. So only then that value I can, concatenate with a inventory stream of sorts, so that I can send it to a microservice and try to understand what is there going to be the dynamic pricing, or when the inventory is going to sell through based on the demand you're seeing. So basically we are doing an aggregation here, and afterwards what we are doing here is we are doing a join. So basically the clickstream and the inventory data which is coming from Shopify, CDC data, both of them, and then doing a inner join. So this is what KSQL queries are. Now I have a setup through which I have already set this up, but let me show you the data I have here. like I mentioned, I'm just showing the topics we have. So this is the clickstream active. Okay, so yeah, Shopify clickstream is the input data which comes in, and then the Shopify products is the data. Sorry, PLF products update. This is the data which basically you get whenever there is a CDC in Shopify. Now using that, as I said, KSQL creates internal topics. One for the clickstream activity, which is created from the clickstream, and then the product updates, which is created from the products update table, and just filtering. And finally, product clickstream is the topic. So this is the topic which we are creating after joining everything. I just want to, like consume from this and show you. You see here, this is clickstream data I talked about, so which is being produced here. So we are consuming that, and let's go and make a change in the Shopify CDC, and then observe this particular joined stream which we have, so and see if that comes up. So I'm just going to. So this is my Shopify account. I have some products here, so I'm just going to change the inventory here. Okay, I have updated it now. So if you see here, we have gotten the entry here. So we can see that, so whatever I updated has come here. So basically this product has 4 variants, so it automatically gives the other variants as well. So in addition to the ones we changed. So we can clearly see that the data we have here is the product related information like product ID, variant ID, variant created at, and then variant SKU, the price, and then the inventory quantity, which is what is the current inventory quantity we have. So now, actually this data I'm going to send to 2 different services. One is for the dynamic pricing prediction service, and another one is the sell-through date prediction service. So dynamic pricing I have already talked about. What is sell-through date is basically you want to understand that, okay, this is the inventory I have so much demand, so when is it going to get 0? When is it all of them is going to sell through, right? So to understand that, we have the sell-through date, and the application of sell-through date basically enables you to, like say that, okay, I don't want to spend any more budget on my ads on this particular product because anyway the inventory is going to hit zero. So for this particular purpose, we have sell-through rate and it is useful. So let me just quickly, like consume that stream and show it to you as well. So this is a sell-through date connector. Okay, this is the topic which returns with the sell-through date. So basically, we have set up a HTTP sync connector, so which every time the data comes in here, right, in the other stream, it's get returned to the HTTP endpoint which you have given. And whatever response it comes back, we are storing it in this topic called sell-through connector success. And this can be used for any downstream activity. But if you see what do we have here, basically we have the same details as here, activity count and things like that, inventory management, quantity 56 here. I think this is matching with this one, right? So if you see the exact data you're seeing here, and in addition, one data we have is the sell-through date, which tells us, okay, it's going to sell through by 23rd April. So this, what can you use this data for is like, go and tell your downstream applications to, like make sure you restock it after this particular date. Maybe I want to go place my order to my manufacturer. And then, I want to reduce any spends on this particular product variant until this date, because anyway it is going to sell through. So similarly, I have one other stream for the dynamic pricing. Okay, so here the same schema, only thing is instead of sell-through date, you are getting a dynamic price. So basically you will need to adjust your price, from 1200 to 1320 of sorts. So because based on the demand you are seeing, which is our clickstream data, right? We want, and also the inventory, whatever is the available inventory, we are arriving at a dynamic price to make sure that you are maximizing your, basically, the customer's ability to buy it, basically. So that is what the dynamic pricing here is doing. So this is just a small demo of how you can do things. So we will share this repo with you so you can go and play around with it. So to conclude, what I want to say is, like, we have the ability to do a lot of different analytics and build models to make your whole pipeline from manufacturing to the end customer. All of this thing can be optimized and made much more effective only if you have the data in a technology where it can serve a lot of applications downstream, and it also can scale well with more and more data you're seeing. So all of these things needs to be taken into account. And considering all that, retail industry would do well if they have a architecture like what we saw, like an event bus like Kafka or something similar to that, which can handle all of this. So that covers most of the talk. So I will take questions now.
How are you joining in?
So that's what I showed you, the KSQL query, right?
What is this?
What is the?
What is this KSQL really? Where does it run?
KSQL is a server actually. It runs, okay. So you see a Docker compose file, right? So these are just the services I'm running, okay? So this is the broker service, which is like Kafka you take. And Kafka is additionally, Kafka Connect, right? Kafka Connect is, it's like where you can have external data come into Kafka, and also from data from Kafka, you can write it to outside system, right? So for that connection, we use something called a connector. So now I'm having a connector here, which is how I'm bringing in all the data as well. Now, after bringing in data, right, I will need to do some manipulation with the data. So what I will need is some sort of like a stream processing application. So KSQL is one of the offerings directly in Confluent, where you can, it uses underneath Kafka streams, and you can build, like a processing pipeline, complete topology of, okay, this is my input, I want to do a filter, join, map, whatever, and then this is the output. Basically reads from Kafka topic, writes back to Kafka topic.
So is there a window that you query on? Because it's stream, right? So
Stream. So basically, when you are doing a join, right, there are different joins that are possible. One is a stream to stream join. Others are all, there are other ways you can do, like stream to table and then stream to something called a global K table. So these are 3 ways you can do it. So when you do a stream to stream join, what you said makes sense. Like you need a window. Obviously, within a bounded window, you have to join 2 streams. But what we are actually doing is, we are doing a stream and table join. So the clickstream data I got, I'm actually doing an aggregation as I get. So for example, like last 1 hour, what is my, number of content views or number of add to carts, and who are the users who have done it. So basically I'm aggregating that and keeping a table. Now as the stream comes in from the Shopify, right, CDC, I'm just joining those 2. Stream and table join, you don't need any window. So you can directly do a stream and table join. Only thing you need is the common field which is there in both the table as well as the stream. Over your head. Please, maybe you can ask questions, I can answer more and more.
You were mentioning about the inventory part, right? If the inventory is low, then the price very likely will be high. So it's not necessarily, for every product it's the same, right? For example, let's take clothing or something, then when the inventory is low, actually the price would be lower, correct?
True.
So how does that, how do you, accommodate those in the machine learning or the algorithms?
Yeah, so here I have not used any inbuilt models or such. I'm just having a thing. But generally, if you see, it is very the customer dependent as well as the what field you are in, right? What type of product. So it is very dependent on that.
Absolutely. Yeah.
So obviously, that is where the model is like you start making the rules. So you have to define what rule you have. And based on that, then you can start building your models on top of that, saying that, okay, this has to follow this particular trend. So if not, I'm going to, tune my model. And slowly, that's where I shown that, evolving of the, basically the microservices. Here, what you're talking about is the microservice.
Absolutely.
So what we are trying to do here is just making sure that the data is there and it is coming real time. And it is available for the microservices to consume and make predictions and also send to downstream. How the microservices itself is working is something which is very dependent on the company and what type of products they are selling. That needs to be built by them only.
Okay, so it's more about the data collection and then the availability of data.
Exactly.
So that
So it is
that part of the service is what you're providing.
Yes.
Okay, great. Thank you.
Okay, any other questions? So we'll share the repo and once you have the meetup link, right? In that we can put. Okay, sure. Okay, you can feel free to reach out to me. Do you have that email ID thing? Okay, sorry. 1 second. I think you can definitely reach out to me anytime and I'll be able to reply back to you. Okay.
thank you so much, Ashwin, for that wonderful talk on real-time retail.